Okay, here we go. We have got some pretty cool word problems here, and these are the session 2 ones. They're really good because they require you to draw pictures. It's not just a multiple choice, and there's lots of ways to do these. And these are real life problems, so they're pretty cool. So let's get started with this one here. Okay, make sure I got a pen that works. Yay. All right, here we go. Abdi has 2 electric train sets. That's pretty cool. A and B. Okay, so Abby doesn't, they're just named A and B. I don't know why he doesn't name them something a little better than that, but there you go. Each train is on its own circular track. He starts both trains at the same time, so that's pretty cool, having 2 trains. Train A returns to its starting point every 12 seconds. Okay, so we can imagine train A is making a circle every 12 seconds. Train B returns to its starting point every 9 seconds. If the trains continue traveling, what is the least amount of time in seconds that both will arrive at the starting points at the same time? So that they will both arrive, both trains arrive, starting points at the same time. So I'm going to take what I've looked at, the information, and I'm going to suggest you do this too, and take this information that's out of here in this written format and make some little bullets. So first of all, we have 2 trains, and they're on a circular track, and so I've got train A, so I'll just put train A, and says it's on a circular track. It makes a circle, and that's every 12 seconds. Train B. Train B is on a circle, and it makes its circle every 9 seconds. And so then this next thing I want to do is I actually want to draw this out and just get an idea of what's going on here. So we've got this, so let's imagine, usually you put these train sets are on kind of a big board here, and you got the train station here like this. So train A is going to go out, and let's do train B first, okay? Train B is a little faster. So it's going to go out, and it makes this little loop, comes back, and that's train B. And that is 9 seconds, right? 9 seconds. Let's get a different color. Now we're going to imagine you've got train A. Train A's loop is a little bigger. It takes a little longer. That's train A. And train A takes 12 seconds. So you kind of get the idea. Train A is going around. This is going around this loop. It's going around this loop. And it comes back every 12 seconds. Then it goes again. 12 seconds. Okay? And 12 seconds is, if you're on a model train, I didn't draw it very well, but if it was going out and around and back, that makes sense because, it doesn't take that long on a model train. So I probably should have drawn this a little bigger. Here's train B. Train B is going out, and it's coming back every 9 seconds right there. It takes off, and it's just keeping looping every 9 seconds. So and actually let me do, so train A would be on this track like this, okay? And then train B would be on this track, right? We'll say they're on kind of like separate tracks. But when do they reach the same point here at the same time? So B is going around in a circle every 9 seconds, and here's A is going, B every 9 seconds, and A is going every 12. So when would they come back together? So at least we have an idea of what's going on. So let's put all that on a number line. Really easy to see on a number line. So let's come out here like this, okay? And let's do train A. I think I was using this color. So A is every 12 seconds. So here's A, and A comes out, and we'll just do a big jump. So there's 12 seconds, and we're going to pretend that this is where it comes back to this part of the station. So this jump just kind of is a way of showing, okay, every 12 seconds. Then another 12 seconds, and it comes back. So 12 plus 12, 24. And you can start to see what's happening. You'll see a pattern here. Okay, so you agree this is every 12 seconds, and this is train A. Okay, this is A. Then B is doing something different. So B is going a little faster. So there's B, and it goes 9 seconds. Then another 9 seconds, it comes back. So now we got to do 9 again, and that's 18. Okay, and then another 9 seconds, and that's 27. And you can see what's happening. 9 seconds plus 9 more seconds, 18. And I'm not drawing the jumps as well as I should. They should all be, you know, a little smaller, and my number line's not great, but that's okay. It's just giving you an idea. That's what you want. You want to be able to draw these things out. And so another 9 seconds is right there. So when do they first come together? When is the least amount of time where both trains are in the same spot, where they both pass through here at the same time? And that is in 36 seconds. And we did that just by drawing a picture. Just by drawing a picture and a number line. What they're trying to get you to learn here is the least common. And what are you counting here? What are these called when you're doing 9, 18, 27, 36? Those are just multiples. So really, this is a problem that you could recognize as least common multiple. And then you could have said, oh, okay, well, there's the first train, 9, 18, 27, 36. You could have just listed the multiples and said, oh, okay, 12, 24, 36. Oh, there's the first time they have in common. You could have done that also. But there's nothing wrong with drawing these problems out, thinking them through, trying to visualize them. Always try to visualize what's going on. Okay, let's check out the next one. Great job. Okay, here, this is a problem. This is a problem where you have somebody selling some things, and it's like running a little business here. So let's check it out. Winston earns $140 selling 56 hot dogs. There's Winston, okay? He's a business guy at a concession stand at school. And using the same rate for the cost of one hot dog. Okay, so a rate, you know, that now you're really talking about a unit price here. Okay, that's a type of a rate. How many more hot dogs does he need to sell to earn a total of $175? Let's take these facts and let's arrange them so we can think it through. So what's going on? First of all, he has sold 56 and he earned, and see, I'm not writing everything. This is just notes for me. He sold 56 and earned $140. Okay? And let's go down. What's our next thing? Our next thing is we have to find the rate for one dog. So we need the rate. And we can just say the price. Price of one hot dog. Or one dog. One dog. Okay? What's the next thing we need? How many more hot dogs does he need to sell to earn $175? So he wants to earn $175 altogether. Okay, he wants to earn $175. He already has earned $140. So how much more? How much more does he have to earn? Okay, so now we can kind of start thinking this thing through a little bit. So he has sold 56 hot dogs and he earned $140. They're saying that we need to know the price of one hot dog. He wants to earn $175, so he's almost there. How much more does he have? So how much more? And then the question is, how many? Oh, I guess I should have, sorry. Instead, I should have just said, how many more hot dogs? Okay, sorry about that. How many more dogs to sell? Okay, how many more hot dogs to sell? Okay, so that's what we're looking at here. So first of all, now let's go and take a look at how much more he needs to earn here. So before we find that, we're like, oh, how much more he needs? He wants 175. He has 140. So 175, 140. What's the difference between those two? So hopefully you can see he needs 175. He has 140. He needs 35 more. So he needs 35 more dollars. But that's not the question, right? The question is, let's go back to that question. how many more hot dogs? Ooh, all right, so we got to figure this out. So, well, how much is he making for each hot dog? So that's what we got to go back and see. So let's go ahead and do that then. That was one of the things that we had back here is how much is one hot dog? So let's go and find out that. So we have $140 and he sold 56. So let's figure that out right down here. How much more hot dogs? Let's do it right here. 140, divide that by 56. Okay. So then what you would do is you could do you would say, well, I got 56 times 1 is 56, so I know that one. 56 times 1. How about 56? What about 2? 56 times 2. Can I get two groups of 56 in there? Let's see what we got here. So we'll multiply this out, 112. How about 56 times 3? Can I do that? I don't think so. I don't think times 3 is going to be a little too much here, right? 6 times 3 is 18. 3 times 5 is 15, 16. So I can get 2. So it's looking like these are going to be $2 and something. Okay, so that's 112. And let's subtract. So we have 3. We'll make that becomes 10. So hopefully you're okay with all of that. So now I have, okay, now I have 28 left over. So now, because I'm interested in finding out how much the cost, I am now going to start breaking this into smaller pieces than the whole dollar. So because I'm going to have a cost that's like $2 and some cents. So I'm going to break it in from dollars. Now I'm going to start, and I am going to break this into tenths now. So that's why I'm bringing that 0 down. Okay, so I'm looking at 280 and 56. So 56 times 2, that's 112. So I could just say, hey, what if I did 56 times 4? I don't even have to do that, because what I can do is say, well, what's 112 plus 112? I don't know if you see that or not, but there's 56 times 2. So if I do times 4, I could just double this. And hopefully you'll see that's 224. So the question is, can I go higher? So I'm going to try 56 times 5. Okay, and that's going to be 0, 3, 5 times 5 is 25, 26, 27, 28. So it turns out this can go, now I have a decimal here, and I should have done this right away, because you have to keep your place value. So now this is the tenths place, and this is the ones place. So I have 5. So each hot dog is $2.50. So the price of one hot dog is $2. I can come up right up here, $2.50 so that I have it, okay? All right, I took care of this, and I took care of this. Check it off. I know he wants to earn this, so now I'm really getting close. So now I have $35 more, and I have $2.50 per hot dog. Per hot dog. Okay, so how many of these $2.50 hot dogs is it going to take? So I could just start adding them. I could just start multiplying. I could divide. So a lot of ways to do it. But let's go ahead and try division. Let's say we have our total is 35. And we'll go ahead and do this in a different. So our total is 35. Okay, so 35. And we'll divide by $2. And I'm just going to put on like this. I'm not actually going to use that other 0. I don't need that. So what's going to happen here? I want to show you something really fast, because when you're dividing out here with this decimal, there's a practice, and what you learn is, oh, you just move the decimal here and you move the decimal there. But I want to show you why that happens. So this is 35 divided by $2.50, and I can write that just like this. I can write 35. I can write it in fraction form. Agreed? I can do that. And I can also, let me get myself out of the way here. I can also say, well, you know what? That's the same as, I can write an equivalent fraction. If I multiply this times 10, and I'll show you why I'm doing that, $2.50 times 10 is equal to, hopefully you know that on a place value chart, I'm just shifting that over, and it's equal to 25. That's what happens. So now I got rid of the decimal point, and 35 times 10 is 350. So in other words, these are just equivalent fractions, and also this is in fraction form also is another way of showing division. So look, 35 divided by $2.50 is the same as 350 divided by 25. And that's why you'll see people say, oh, you move this decimal over here, and the decimal was here, right? And you're going to move it over. That's why they do that. Now what I like to do is just copy everything down so it's not all messy and say, okay, I'm moving the decimal in both of those. Why am I doing that? Because actually what's actually happening is you're doing this, but we don't really go through all this work. It's just an accepted practice, kind of like when you do keep, change, flip when you divide, fractions. But because of that, I can do 350 divided by 25. All right, well, let's go over here. So we've got, let's go one time. So we have 25 will go in there one time. We subtract. We have 100, and hopefully you'll know, okay, 25, 50, 75, 100, that's going to be 4. 4 times 25 is 100. So the answer is, how many more hot dogs? So he needs to sell, you would write this, he needs to sell 14 more hot dogs. And so just take a look at this problem. If you can work through a problem like this, look at all the steps. First, you had to find out the price of one dog, the price of one hot dog. And that's what businesses do. They have to find out, well, what's the price? How much is this really costing us, okay? And then we got to find out, well, they had a goal, they had a target. He wants to make $175. Maybe he's going to, he's saving you money. So he has that goal. So he needs 35 more to reach his goal. And now he has to do another step and find out how many more hot dogs. So it's a lot of work, but that's 6th grade. It's very practical. That's the kind of stuff you're going to be doing. So at 6th grade, you're doing math that people are using to run a business. So it's pretty darn cool. Pretty darn cool. Okay, let's do one more and we'll finish up. Okay, I think this is the last one we're going to do on this. And we're going to read through and again, just show you how to use some really good common practices here. At the end of a baseball game, the players were given the choice of having a bottle of water or a box of juice. Of all the players, this is worded kind of funny, of all the players, 12 chose a bottle of water. So not all the players chose water. It just says of all the players, 12. So 12 is just a part of the total. Okay, parts and wholes. And it says 12 chose, which was, so the 12 people represents or was 3/4 of the total number of players. So right now we've got, and you're always going to have at least 2 numbers in a word problem and then 1 unknown. Same thing, you'll notice that all the time for the majority of these word problems. 12 chose a bottle, that's 3/4 of the total. Okay, what do they want us to do? Write and solve. So be careful, they're asking for 2 things. Write and solve an equation to determine P. Well, what in the world is P? The total number of players at the baseball game. Okay, all right, let's put this in bullet form. Number 1, we have 12 chose water. Okay, and then we have 12 chose about, which was 3/4 of the total number of players. So actually what I'm going to say is I'm going to put that into, in other words, 12 is 3/4 of the total number of players. I'm going to put it in this form. 12 is, because that's what this is saying, 12 chose, and that is 3/4. 12 is 3/4 of the total players. We can put players like that. Okay, so 12 is 3/4 of the total players. Now we got to write and solve an equation for P, total number of players. Okay, so now that I've got this, I'm going to show you a really cool trick. Certain words translate right to the math code. I don't know if hopefully you saw some of the other videos, but we talked about kind of that math code or math language. Math code or math language, okay? So basically we're going to take this statement here, 12 is 3/4 of the total players, and we're going to put it in math code. So let's do that. It's really easy. So we have 12. This is pretty cool. Is in math, is stands for just equals. In other words, you know, just like saying 2 plus 2 is 4. You can say 2 plus 2 is 4, or 2 plus 2 equals 4. So, you know, right away, we can start to set up our equation here, okay? 12 is 3/4 of. This word of, 3/4 of the total. Of always means, when you see a little fraction like this, times. 3/4 of means 3/4 times. That's what we mean. Of the total players. And they already told us up here they want to know. They said P is the total players. So what we have is 12 equals 3/4 of P, 3/4 of the total. So now we got to solve. So there's our equation. So there's the equation. We wrote the equation. Now we got to solve it. So you can solve this equation, and I don't think you've done a lot of this. Pretty sure you're just getting into the algebra. You can solve it with algebra. You can solve it by thinking about how to do it algebra, or you can solve it by thinking about just how a fact family works, or you can just draw a picture. Okay, you can just draw a picture. So I want to show you the picture first, because I think that's pretty neat. Here's a picture of this one. Let's do this. 3/4 of some total is 12. So wholes and parts. Big idea again. You got wholes and parts. Huge idea. And how do you draw a hole? You can do it with a tape diagram. That's why they've been teaching those darn tape diagrams for so long. Because that's, you just draw the hole. So there's our whole thing right there. There's the hole. And now, how do we draw 3/4 of that? Easy. You know fractions, so you can just divide this up into parts. It's pretty cool. Okay? And I'm going to divide it into 4 because that's what that's telling me. I've got 4 parts here. And I'm going to just kind of shade in 3 of those. Right? Because 3/4 of them. Now, what do you know about the 3/4? That's 12. So 12. So you got to fit 12 in those 3 boxes. So what would go in each one of those boxes to get 12? You can do it. You got that easily. You got it. You got it. It is 4. 4, 4, 4, right? 4, 8, 12. That stands for, that's the 3/4. And the really cool thing about tape diagrams is once you've filled in part of it, well, then you know. So now you know the total. Pretty cool, huh? So the total is actually this whole tape diagram. 4, 8, 12. You got it, 16. So we just solved it. We just literally solved it. We solved that equation, okay? We showed our work, and I would certainly give you credit for that. How can you solve it? And there's another way to solve it too. You could just recognize, I think at this point, recognize this is a fact family, okay? So let's just imagine I have, let's just pick some friendly numbers like 16 equals 2 times something, okay? We'll just put 8 in there. We'll put 8 in there for now. 16 equals 2 times 8. So what are the fact families? Well, you could do 16 divided by 2 equals 8, couldn't you? So look up here. We could do the same thing here. 12. This is like a fact family. 3/4 times something. Even though it's a fraction, you could think of it as just a fact. 3/4 times something equals 12. So we could also do 12 divided by 3/4 equals what's left over. Just like I did here. 16 equals, right? See that? 16 divided by 2 equals 8. So then if I come back, if I were to let this thing, if I were to put P in here, 16 divided by 2 equals P. I could solve it. So let's do that. Let's do that. Let me get these guys out of the way, and then we could solve it. Okay? Now we're gonna do some division of fractions, and I got a couple of cool ways to do that. Here we go. Okay, so we have 12 divided by 3/4 equals P. Hopefully that's going to make sense. 2 ways to do this. You can make a common denominator or you can go and use your keep change flip. So I'm going to make a common denominator real fast, okay? So I have 12 over 1, and then I want a 4 in my denominator. So hopefully you know how to do that. I'm just going to make an equivalent fraction to this. So I'm going to say times 4. 1 times 4 is 4, and 12 times 4 is 48. Okay? Now I'm going to erase this little part here. So this is my equivalent fraction, but I want to just get this out of the way so it doesn't confuse anybody. And I can say 12, which, by the way, 48 fourths, 48 over 4, or 48 divided by 4 is 12, divided by 3/4. My denominator is the same. I don't have to do any flipping of anything. These are just the same parts. I got 4 parts and 4 parts. So what's 48 divided by 3? 48 divided by 3. Well, I'm running out of room here. I'm going to do it over here. So 1 time, it is 16. That's my answer, 16. That's what P equals. Now I'm going to come over here. I'm going to clear some of this stuff out as well so that doesn't get too confusing, and I'm going to use the keep change flip. And I want you to watch. There's something pretty interesting about the whole keep change flip business here. Watch this. Ta-da! Let's do green. So over here, you know that you probably learned that keep change flip because I'm dividing fractions. So here I go. 12 divided by 3/4. Remember how you learned that? You keep the first term, 12, times, change the next one to multiplication, and it's 4 over 3. I'm going to write this now as 12 over 1. Now watch what happens. Watch what happens. It's the same thing over here. Watch this. Watch this. 12 times 4 is 48, and I end up with what? 3. So guess what you have to do? You still have to do 48 divided by 3, and look over here. That's what we ended up with, 48 divided by 3. Okay? So the reason the keep change flip thing works is because they're actually having to make kind of like they're using the concept of a common denominator. Okay? So we solved that in 3 different ways, and we could have done more. We could have done more. Pretty cool problem. All right, great job, great job. Thank you.